Okay, today we're going to do our last lecture on different kinds of graphs and visual representations of descriptive data. Okay, so we want to do line graphs. Here we have a table that shows from 40 people surveyed, how many times did they have to remind their teenager to do their chores? Okay, and it's a frequency table. Do you see that? So, 2 people said they never had to remind their child. 5 people said they had to remind them once. 8 people had to remind them twice, and so on. Okay? All right. This is categorical data, not continuous. Okay, there's no such thing as reminding somebody 3.78 times. Okay, it's either 3 or 4. See what I'm saying? So that's categorical data. So you can make what's called a line graph of this, which is just the type of graph you're used to from math classes. Let me post one in here for this data. Okay, you see on the horizontal axis, they plotted the number of times the teenager is reminded. That's our categories here. 0, 1, 2, 3, 4, or 5. That's our categories. And then for each category on the vertical axis, they plotted the frequency of that category. In other words, how many times does that category show up in the data? So 0 showed up twice. 1 showed up 5 times, which is actually not on the graph because they only listed the, it's not on the axis, I mean, because they only listed the even numbers. But you see that right there would be 5. Okay. 2 showed up 8 times. 3 showed up 14 times. 4 showed up 7 times, and 5 showed up 4 times. And you see you get a point. Zero, 2. That means 0 had a frequency of 2. You get a point for each category and its frequency. 1 had a frequency of 5, and so you get a point. 1, 5. You see how that is? This is just the type of graphs you do in math class usually. Okay? That's a line graph. Notice that this is for categorical data. Okay? Now something very, very similar is called a time series graph. Here, I should label this. That was a line graph. Remember, that was for categorical data. Now, let's do what's called a time series graph. Now, this is a little bit different. A time series graph is where you record one measurement, kind of like up here. They were recording one measurement up there, and that measurement is how many times does a teenager have to be reminded? Okay? Down here in a time series graph, we're going to record one measurement, but instead of doing it for numerous different people and then breaking those down into categories and graphing the frequency, what you do in a time series graph is you take one measurement at multiple different times, and then you list the times on the horizontal axis and the measurements themselves on the vertical axis. Let me show you. Okay, over here we have the annual consumer price index. Okay, for each year. What they've done here is they've done this for multiple years, okay? 2003, 2004, 2005, and so on, okay? Each year. Now they did it for every month. This particular table only shows starting in August, but January through July comes before that. It just didn't fit in this table. But what they did then is they made the average for the year. And that's these numbers. That's the only ones we need to look at, the yellow and the green. Okay? So for each year, which you put on the horizontal axis, you plot a point for the measurement. In 2003, it was 184. You can't see the individual points, but there would be a point right there. 203, 184. In 204, it was 88.9. In 205, it was 95.3. In 206, it was 201.6. And so on and so forth. And then you connect those points. Okay, so it's a type of a line graph in a way, but what's different? I want you to pay attention to this. It's not just the fact that this involves time. There's something else that's different. Look at this one up here. What was that? Here they graphed the frequency of each measurement. How many times did each measurement show up? That's on the vertical axis. Here on the vertical axis wasn't the frequency of the measurements, it was the actual measurements themselves. What were the measurements? Okay, and you can do a line graph that way as well, but when the difference is that in a normal line graph, you are measuring at one time, you're measuring many different people, let's say. Whereas in a time series graph, you're measuring one person many different times. You see the difference? Although in this one, it's not measuring a person, it's measuring the consumer price index. But do you see what I'm saying? For a normal line graph like this, you're measuring many different objects at basically the same time. Whereas here, in a time series graph, you're measuring one object at many different times. Okay? All right, and then the last kind that we need to cover is called a frequency polygon. Now, this is for continuous data. You're going to see a very similar thing between a line graph and a frequency polygon. Okay? The difference being that a line graph is normally for categorical data, a frequency polygon is normally for continuous data. So it's very similar to the difference between a bar graph and a histogram. Bar graphs are for categorical data, histograms are for continuous data. Line graphs are usually for categorical data, frequency polygon is usually for continuous data. Okay, here's how a frequency polygon works. Look at that table right there. Okay, this is the test scores on a calculus final exam. Okay, now that's continuous data. I'm going to say this again. I say it all the time when continuous data comes up. Notice that it appears as though they have rounded off all the scores, or maybe they didn't round it off. Maybe that's the way the teacher graded them in the first place. All the scores go to 1 decimal place, right? or at least that's the way they've been grouped. But, so you might say, well, then that's not continuous. But the point is that the teacher could grade these to however many decimal places they wanted. You could have a 78.2376%, right? So it is theoretically continuous data. Okay? All right. What they have done is they have, like we often do in continuous data, like we did with histograms, we separate into intervals. Okay? And so what they've done is this. They've separated the scores into intervals. The first interval goes from 49.5 to 59.5. And 5 people got that score. 5 people got between 49.5 and 59.5. Okay? And then 10 people got scores between 59.5 and 69.5. 30 people scored between 69.5 and 79.5. And so on. 40 people between 79.5 and 89.5. And 15 people between 89.5 and 99.5. Okay? We're not going to look at the cumulative frequency for this graph, but I do want to just remind you of what it is. The frequency is how many measurements came in for each interval. The cumulative frequency is how many measurements came in for everything in that interval or lower. So let's choose a new color here. So for the lowest interval, the cumulative frequency always equals the frequency. But then for the next one up, for the second interval, the cumulative frequency is the sum of the first two interval frequencies. 5 and 10 together makes 15. And then for the next interval, the frequency was 30, so you add on 30, and the cumulative frequency becomes 45, and so on. Okay, but we're not gonna graph that. We're only going to graph the frequency. Okay, and here's what you do. For the first interval, which goes from okay, 49.5 to 59.5. Okay, let's just write that here. This is actually going to end up being the second interval. You'll see why in a second. Okay, 49.5 to 59.5. Okay. All right, what we're going to do is we're going to pick out right in the center of that. And that's going to represent that first interval. Okay, what's right in the middle of 49? What's right in the middle of 49.5 and 59.5 will be 54.5. Okay? And then what is the frequency for that interval? It's 5, right? So I'm going to go up here. 1, 2, 3, 4, 5. And then we plot a point. Okay? Now, what's next? 59.5 to 69.5. What's right in the middle of that? 64.5. That one number, 64.5, is going to represent that whole interval. What's the frequency for that interval? 10. So you plot a point there. You see how that works? And you do that for all of them. I'm going to stop drawing it myself, and I'm going to show you the picture straight out of the book. It's much nicer and neater. But you're going to see something at the beginning and the end that might throw you off, and I'm going to explain it, so just hold on a minute. Okay, here's our picture. All right, I'm gonna go through this picture with you. Okay. So let's kind of start over again. Okay. So the first interval, (49.5 to 59.5). The middle of that is 54.5. Don't worry about this over here yet. I'll do that at the end. Okay, 54.5, that's the middle of the first interval, and the frequency is 5. And so you get this point right there. Okay, now let's go to the next one. (59.5 to 69.5). What's right in the middle? 64.5. So that one number is going to represent that whole interval. What's the frequency? 10. So we get this point right here. Okay, and then we just continue. Next one, 69.5 to 79.5. The midpoint is 74.5. The frequency is 30. So we get this point right there. Next interval, 79.5 to 89.5. The midpoint's 84.5. That one number represents that whole interval. The frequency is 40. And so we get this point. And one more. The last interval goes from 89.5 to 99.5. The middle is 94.5, so that one number represents the whole interval. The frequency is 15. And so we get this point right here. Okay, so that takes care of explaining these points. There's 1, 2, 3, 4, 5 intervals. 1, 2, 3, 4, 5 points. Now, what about this point at the beginning and this point at the end? Okay, where do those come from? So what you do is, because our first interval was 49.5 to 59.5, what you do when you make a frequency polygon, this is just one of the rules of a frequency polygon, okay, you put an interval that comes before the first one. So since our first interval was 49.5 to 59.5, we make sort of an imaginary interval right here that goes 39.5 to 49.5. Okay, that's the lower bound, upper bound, and there's not actually any data points in there, is there? So that means the frequency is 0. And the midpoint of that interval is 45.5. Oh, by the way, you have to be really careful. I just want to make sure I point this out. You might think that these 4s down here are just typos, because you might look up here and say, oh, those are supposed to be 9s. But it's not a typo. Remember what I'm saying is that you represent the whole interval with its midpoint, okay? Halfway between 39.5 and 49.5 is 44.5. And so that explains this down here. And the frequency is 0. And so you get that point right there. Okay, and then you go to the end and you do the same thing. The last interval where we recorded anything was 89.5 to 99.5, and what you do is you put one more phantom interval after that, which will go 99.5 to 109.5 and have a frequency of 0. And the midpoint is 104.5 and the frequency is 0, and you get that point. So for a frequency polygon, it should never be floating above the x-axis. It should always touch the x-axis at the beginning and the end, because you should always have a point of frequency 0 at the beginning and a point of frequency 0 at the end. Okay? Now this wasn't a very long lecture, I understand that, but we now completed this part of the chapter, section 2.1. So I'm going to stop here and we'll do 2.1 starting in the next lecture.